Hello students, welcome to AnandsIronLineDotCom. Today I will be discussing one very important topic, Pythagoras Theorem, which comes in SAT, GRE as well as in GMAT. Let us understand the concept, Pythagoras Theorem. See, Pythagoras Theorem states that in a right angle triangle, ABC, right angle at B, AB square plus BC square is equal to AC square. What does this mean? This means that if you draw a square on side AB, then AB square represents its area, right? If we draw a square on BC, side BC, then BC square represents the area of this square. And if we draw a third square on side AC, then AC square represents this area. So basically we can say that area 1 plus area 2 is equal to area 3. Now see, this can also be in place of a square. We can take other figures as well. This theorem can also be extended to different figures like semicircles or equilateral triangles. So if I take semicircles, semicircle on AB, semicircle on side BC and semicircle on side AC. Let me see that again area 1 and area 2 are equal to area 3 or not. See, we are already given that AB square plus BC square is equals to AC square, right? If I divide each side by 4, we get AB square by 4 plus BC square by 4 is equal to AC square by 4. It means this is AB by 2 whole square plus BC by 2 whole square is equal to AC by 2 whole square. So if I take the radius of semicircle 1 as R1 and this as R2 and this as R3, so I've got that R1 square plus R2 square is equal to R3 square. Why I'm taken R1? Because R1 is half of AB, right? So you have taken AB by 2. R2 is equal to half of BC and similarly R3 is equals to half of AC. Now, what is area of a semicircle? If it is half pi r square, right? Half pi r square. So I can multiply them by half pi. Multiplying by half pi on both sides. Right? Now half pi r square is the area of the semicircle. 1, so I write A1 plus A2 is equal to A3. Again, one thing more, case 3, when we extend it to equilateral triangle. Let us suppose we have a triangle ABC, right angle at B, and we have 3 equilateral triangles, one on side AB, say PB, another on side BC, let's say with PQC, and the third one on side AC, let us take ARC. Now these are equilateral triangles. Again, since it's an right angle triangle, I can say that AB square plus BC square is equal to AC square. Now, what is area of an equilateral triangle? If you see, area of equilateral triangle is root 3 by 4 root 3 by 4 times of side square. Area of equilateral triangle root 3 by 4 times of side square. So if I multiply both sides by root 3 by 4, I get root 3 by 4 times of AB square plus root 3 by 4 times of BC square is equals to root 3 by 4 times of AC square. So again we get root 3 by 4 times of AB square means area of this triangle, which is A1. This is A2 and this is A3. So again we have A1 square plus A2 square equals to A3 square. So from case 1, case 2 and case 3, what we observed that in an equilateral triangle, in a right angle triangle, if we draw the squares on each side of the triangle, then also the area of two smaller squares sum up to the area of the larger square. And if we draw a semicircle or equilateral triangle, still this equality holds, right? So this is all about your Pythagoras theorem. Let us do a couple of questions and then we can finish. Question number 1. There is a triangle PQR, right angle at Q. And there are 3 squares. One here. Then we have square on the second side, QR, and 1 square over here. What he's saying? He's saying that the square of the area of square A is 16. The area of square A is 16. This area is 16. This area is 20. He's saying what is the length of side PR? What is the length of side PR? So first of all, we see that area A plus area B is equal to area C, right? 16 plus 20 is equal to area C. It means 36 equal to area C. It means the square PR square is equal to 36. So PR comes out to be 6. Therefore, length of side PR is equal to 6, right? Let us do next question. Question number 2. Yes. We are given a triangle ABC, right angle at A, and AD is perpendicular on BC. AB equals to 10, AC is equal to 20. What is the length of AD? We need to find AD, okay? So we need to find AD. See, first of all, I see that angle A is 90 degree. So first of all, let us find BC. So BC square is equal to AB square plus AC square. It gives me 10 square plus 20 square. So 100 plus 400 gives you 500. So BC is equal to root of 500, which is equal to 10 root 5, right? So BC is 10 root 5. Now I need to find AD. Now, dear students, you can just pause here, solve it yourself, and then proceed. Okay, then you can see my video for solutions. Now I observe that if I need to find the area of triangle ABC, I can do it in two ways. One is I can write half into AB into AC, or I can write area of triangle this as half into, if I take BC as the base, I can write BC into AD. It means since it's the area of the same triangle, we can equate them. So half into AB is 10, AC is 20, is equal to half into BC, which is 10 root 5 into BD. So from here we can find the length of side BD. So what I can do, I can cancel half and half. I can cancel this 10. So 20 divided by root 5 is equals to BD. I can write this as 4 times 5 or 4 times root 5 times root 5 over root 5 equals to BD. So this and this cancels out. We get 4 root 5 is equal to BD. Hence the length of side BD is 4 root 5. So my dear students, hope you have understood this lesson. To like it, share it and subscribe it. Thank you so much for watching.